Okay, next we start our discussion on frequency distribution graphs, putting our data into graphic or picture format. And we make some distinctions when we're graphing data from a sample versus graphing data for a population. Again, there's a little bit of wiggle room in how people think about these across the board, but on the whole, the kinds of graphs we use when we're graphing data from a sample are different than the graphs we use for populations. Usually, not always. So first of all, this is our data that we used initially when we started building frequency distribution table. So we need some data to work with. So I'm just putting back up there the exact same data. So there's 1 5, 3 4s, 5 3s, 3 2s, and 2 1s. So it's exactly the same data setup we had before. So the first type of graph we're going to make for this data, assuming that it came from a sample, you can see is called a histogram. So the first thing we do with a histogram is the first thing we do basically when we were doing a table, we've got to get our workspace set up. So the first thing we want to do is build a blank graph. Now, in general, I don't get too picky about looking at this, but in general, the vertical axis here should be about 2/3 the length of the horizontal axis. So this should be just a little bit longer, about 1/3 longer than the up and down axis. Before we finish plugging in here, I'd like you to go to box 2.1 in the regular textbook. That's page 45. So go ahead and pause the video for a second and look for box 2.1. Okay, so in this box you see two versions of a histogram. And we can see the top one, the proportions are opposite. The vertical axis is really tall and the horizontal axis is really short. It's almost flipped backward, if you will. And the one below that is the one that's proportioned the way we're supposed to, with this x-axis or horizontal axis about 1/3 longer than the y-axis or vertical axis. The reason why I want you to look at that is because there's a reason why we talk about having our graphs proportioned this way. One of the easiest ways to distort data, to make little changes look like a big deal, or to make big changes look like nothing, is to simply distort the length of these axes. So one of the things that hopefully you're going to get out of this course, really more than the ability to compute statistics, although you're certainly going to learn to do that, the bigger fish to fry here is to interpret, to critically analyze. And so when you're looking at any type of a graph, one of the things you should ask yourself is, why did they draw it that shape? Why does it have these dimensions? There might be a good reason for it, or it might be a way of manipulating you. So again, if we look, the data is exactly the same on those two examples in box 2.1. But where they made the horizontal axis, I'm sorry, the vertical axis really tall, it looks like there's really big differences from year to year, year 12, 13, 14, 15. Wow, those look like it's exponential growth. But if we look at the one that's proportioned correctly below it, things definitely increase from year to year, but not really that much. So there's a reason why these proportions are supposed to be like this. You can, again, violate this rule, but you have to have a good reason for doing so. Otherwise, what you're doing is manipulating. You're manipulating the way the data looks, manipulating the way people respond to it and interpret it. So anyway, we've got our axes up there. We need to label them always. Axes have to have a label, always, always, always. Really, the whole graph should. But so on the vertical axis here, the label is always F for frequency. And on the horizontal or x-axis is always whatever the raw score variable is. So if we were measuring shoe sizes, we would write shoe sizes. If we were measuring IQ scores, we would write IQ scores. What we have in this example is simply raw scores. It's a generic example. So all we can label this as is raw scores. Now your authors often put an X off to the side there. We don't really need that. Some people do, some people don't. I don't. It doesn't matter. What matters is the label. And now across the axes we want to evenly distribute the numbers that we have to work with. So our frequencies go from 1 to 5. So we want to kind of pretty evenly as we can. Kind of cut this into 5. And then the same thing for the X for the raw score axis. And coincidentally, it's also 1 to 5. It'll be a little more spread out now. So 3 put us about there. That's a little off, but good enough for right now. All right, so that's step 1. Step 1 is get your blank graph set up. So we're always looking for axes. We're looking for them to be numbered appropriately, correctly, and we're looking for them to be labeled. All of those things count. You should always be looking for those and doing those when you're building them. Now we're going to actually start to plot the data in there. And there's not really one way to do this, but I'll show you a way that works pretty well. So we're going to start with our lowest raw score of a 1 at the left. Our raw score is a 1. What's the frequency of it? 2. There are 2 scores of a 1. So I go to score 1, I go up to frequency 2, and what I'm going to do is I'm going to put a bar there. I'm trying to get kind of in this halfway zone between 1 and 2. I'm a little smushed into the corner here. I should have been a little further over, but that's what it is. Next one, raw score of a 2. There are 3 of those. So I go over to 2, I go up for a 3, and again, I'm going to try to draw a bar that goes from about 1.5 to 2.5, kind of straddles that middle zone. Raw score of a 3, there are 5 of those. So over to 3, up to 5. Hard to do this sideways. 4s, there were 3 4s, so over to 4, up to 3. And lastly, 5s, there was only 1 5. So over to 5, that a little bit, and only up to 1. Now, all we have to do is ground them down to the x-axis. And if we've done it well, they should overlap about perfectly. Pretty close, especially if you're doing it sideways on a rickety board. There we go. There is our completed histogram. So what makes it a histogram, and statistics has a pretty standardized vocabulary, but this area about graphs is an area where it's a little bit loose. What most people mean by histogram, and what we mean by it, is that it is a graph where the bars touch each other. The bars are right next to each other. This is a graph that you would normally use for interval or ratio level data. So those are terms we learned back in chapter 1. So those are our higher level measurements. What that really means is if our data comes from a sample and it is at the interval or ratio level, this is an appropriate graph to use. The reason why the bars touch is it's supposed to symbolize the fact that usually interval and ratio data is also continuous. Remember, that's the one that has an infinite number of in-between values. And by having the bars touch each other, it shows that there's no missing values in between. All the values are covered somewhere. That's the philosophy behind it anyway. So that's what a frequency histogram, or just a straight up histogram, is for this data. So in the coming video clips, we're going to show a couple other ways of graphing this data for our sample.